Okay, we're looking at the Britney Ruiz case study here. Let's scroll down and read the first question. Question 1. Web is most accurate concerning conclusion 1 and 2, conclusion 2 only, or neither 1 or 2. So let's scroll up and read until we get to these conclusions. Britney Ruiz is the Chief Investment Officer at Blackmount Capital Advisory Firm, BMCA, a leading U.S.-based money management firm. Last year, BMCA launched the BMCA Equity Fund that invested in domestic and international market stocks, including those of Russia, Brazil, Canada, and the UK. During its annual performance review, Ruiz discovered that the fund earned a considerably less return than that of its benchmark. Concerned with the outcome, Ruiz called a meeting with the fund's portfolio management team to discuss key issues related to the quantitative analysis of the fund's investments. A leading quantitative expert, Anthony Webb, was invited to chair the meeting. While analyzing the regression models used by the PM team to predict stock returns, Webb requested the information provided in Exhibit 1. The information relates to a time series model for annualized monthly returns to a Brazilian stock index. So we've got the annualized monthly return to the Brazilian stock index, then we've got the lags 1 through 5, and then autocorrelations of those 5 respective lags. So essentially what this is saying is a lag of one period has an autocorrelation with the index of 0.1320, and then kind of so forth. After his analysis, Webb presented the following conclusions to the portfolio management team. Okay, so this is what we're looking for now. So our conclusions might be based on this exhibit to some extent. So let's see. Conclusion 1. This time series can be best modeled using a moving average 2 rather than an autoregressive model. So one thing we're going to need to do to calculate this, and let me just pull in this info. Oops. Yeah, there we go. So we've got standard error is going to be 1 over number of observations to the 0.5. And this is going to give us a number of 0.05012. So any lags that are above this are going to be a good use of the model. Any lags below it are going to be are essentially going to say that the autocorrelations are not significantly different than 0. So when we look at this, we got 0.05012. So we've got lag 1 and 2 that are above that, and then below these lags, then lags 3, 4, and 5 are below here. So we would say that they're not significantly different from 0, meaning that 3 lags back is not going to help us predict the stock market returns to any extent. So given that, we can conclude that moving average 2 model, so MA2, that's going to say basically the lag 2 is going to be our best model, which is correct since that is the highest number above that critical value. So we can say conclusion 1 is good so far. So let's look at conclusion 2. And I guess what we could do right here if we were pressed for time is most accurate concerning. So he is accurate concerning conclusion 1. Conclusion 2 only we could rule out in neither conclusion 1 or 2. So if we were pressed for time, we could just go ahead and go with A by process of elimination there. But let's look at conclusion 2. A moving average 2 model would be different from a simple moving average because the former would place different weights on the terms in the moving average, and unlike the M2, a simple moving average is based on observed time series values. And so this is also going to be a correct statement. Don't have any advice really on solving that other than just kind of knowing and understanding that, committing that to memory. So 1 and 2 are both right, or are both accurate, so we will stick with answer A. Question 2. Is Webb's conclusion regarding the presence of a unit root in the inflation rate time series most accurate? So we've got yes, his conclusion's correct. No, it's not correct because the regression variables that he used in his computed t-statistic were incorrect. Or no, because his application of the regression-based unit root test was incorrect. So we left off after conclusion 2 right here, so let's start reading. Since 10% of the BMCA equity fund was invested in large cap Russian stocks, Webb considered it crucial to study the characteristics of the Russian capital markets. While reviewing BMCA's autoregressive model used to predict the Russian inflation rate, Webb suspected that the model might have a unit root. To accurately test for the presence of a unit root in the time series, Webb decided to regress the first difference of the time series on the first lag of the time series. So this is one of our things here was because he regression variables he used in computed t-statistic were incorrect. So this looks good so far from a regression standpoint. When we're looking at testing for a unit root, we're basically trying to determine whether there's stationarity, and so whether the data from one period is influencing data from the next period. So to do that, you check the correlation based on a lag in the time series, which is what we're doing. So that all looks good so far. So B is not really looking like our answer yet. After obtaining the regression results, Webb calculated the t-statistic conventionally for the coefficient. He then used the critical t-values computed by Dickey and Fuller to determine significance. This all seems good so far too, so I think we can go ahead and rule out B, and that leaves us whether his conclusion is correct or whether it's not correct, which we have not gotten to yet. Let's see. So then last sentence, since he could not reject the null hypothesis at the 5% significance level, Webb concluded that the series did not have a unit root and was stationary. So I'm just going to pull this in here. So the null we're testing in this scenario is going to be that the null is that it has a unit root, indicating non-stationarity, which is what it looks like we're testing on, but that leads Webb to conclude that it does not have a unit root and was stationary. But if we can't reject the null, this basically gives us inconclusive evidence. So his conclusion is going to be inaccurate, and that's going to leave us with answer C, no, not accurate, with the application being incorrect. All right, question number 3. Webb is most accurate concerning statement 1 only, statement 2 only, or neither statement 1 nor statement 2. So we left off right here. Let's read down until we get to those statements. When talking to Ruiz about random walks, Webb stated that a time series that was a random walk could not be analyzed using standard regression analysis. He made the following statements. Statement 1. There is no finite mean reverting level for a random walk. In addition, the variance of the time series increases or decreases as we go further into the future without any upper or lower bound. This violates the assumption of a finite variance for the time series. So this is going to be incorrect because with respect to the lower bound, there is no upper bound essentially, but we can only go down so far. An investment can only go to 0. So the statement 1 is going to be incorrect, which leads us to rule out A. So now we need to figure out whether statement 2 is correct or not. Statement 2, to model a random walk, we should first difference it. This results in a mean reverting level of 0. In addition, the variance of a first difference time series is not only finite, but it is also constant. The time series then becomes covariance stationary. So this is accurate. We want to make sure that our data set is has stationarity so that we can assess the mean reverting level being 0, meaning that we don't want our data series to kind of be going up and up and up and up like this to analyze a random walk. We want it to be going more in like a straight line across in order to analyze it properly. So that's what this is kind of getting at. We would go from this to this by kind of doing that first differencing. So we can conclude that statement 2 is accurate and go with B. All right, we're looking at the last question on this case now. With regards to his comments about random walks, Webb is most likely correct, incorrect about the criterion of choosing the correct model, or C, incorrect about using first differenced AR models and the criterion of choosing the correct model. So we left off under this last comment. Let's read this last paragraph here, and hopefully we get our info that we need. Webb continued by stating that if a time series is a random walk, it is best to model the first difference series with an autoregressive model to predict future movements in the time series. He also stated that the key to choosing the correct model, so that was one of our criterion there, and also the first difference AR model, was to analyze each model's R-squared. The first difference AR model would generally have an R-squared greater than the R-squared of the original AR model for a random walk, since the first difference model better fits the data. So looking at these statements here, so the easiest one, or the one right off the bat, is the R-squared. So we're not necessarily just going to choose the better model just based on the R-squared, and it's not always the case that our R-squared is going to be greater. So we can go ahead and cross off the correct. So we know the criterion for choosing the model, that's going to be incorrect, and that's in both of these. So now we need to kind of decide about the first difference AR models. So modeling the first difference AR model series with an AR, modeling the first difference series with an AR model does not necessarily help predict the future. So it's not necessarily going to be the best model, and it's not necessarily going to fit the data better. So I think we can go ahead and conclude that answer C is going to be correct. Answer B is incorrect.